All right, so this is the last lesson for this week, okay? Quadratics review. And with quadratics review, they're just on the benchmark, they're going to test your knowledge if you understand what parts of an equation mean what. How do you find specific things like axis of symmetry, vertex, and things like that? Like, is it opening up or down? How would you know? That type of stuff. So this is all based on errors, okay? So the quadratics review, you can see it actually says cast review. This is taken from their website. So like if you're trying to practice for this stuff, this is the kind of stuff they want to make sure you know how to do. It says for each exercise, identify the error or errors in planning the solution or solving the problem. Then write the correct solution. Okay. So according to the first problem, they said graph this function f of x equals to quantity x minus 2 squared minus 2. How is the graph a translation of f of x equal to x squared? In other words, how does it move? And they said the graph of f of x equals x squared, so the original graph, is translated, so it's moved left 2 times and down 2 times. Okay? It says you're supposed to move it left 2 times and down 2 times. Now, if you look at the formula that they gave us, x minus 2 quantity squared and then minus 2, let's kind of look at a couple of different pieces here. That number, minus 2, which way does it move the graph? Down, right? So this is down 2 times, right? So down 2, that makes sense. That means that the error has to be left 2 units. Remember, if it says minus inside of here, then you got to go right. Okay? This would be right 2 times. Now, if you're wondering, well, then how do I graph that? Well, f of x squared looks like this. Whoops, hold on. Let me redraw that. So if I'm going to translate it, I wonder if I can choose 2 things at once. No, I can't. Let me try drawing this again, but in one swoop. So if I'm going to translate it, right now it's at 0, 0. The center is at 0, 0. So I'm supposed to basically move it twice to the right and twice down, okay? Notice the values are 2s, just so you know, okay? So the values are 2 every single tick mark. So I only moved it once to the right, but that really counts as 2. And then once down, because that really counts as 2. So your graph should be right there on that side, where the green one is, okay? Instead of where they drew the black one, okay? So when you're doing this, you do have to understand how it works. So this was the problem, okay? It's not left, it's right. Okay, now that we did that, I want to remind you guys about that equation. Y equals to A times X minus H. Hold on a second here. Grab one of these. So X minus H, quantity squared, plus K. Remember, A, if A is positive, it opens up. If A is negative, it opens down. Okay? H. So if H looks negative, you go right. H looks positive. Whoops, let me try that again. You go left. That's why over here they put x minus 2 quantity squared. That means that you have to move to the right side. Okay, so because it looks negative, x minus 2, right? It looks negative. That means I have to go to the right. If it looks positive, if it was an x plus 2 quantity squared, I go left. And then your k value. So k is positive, you go up. K is negative, you go down. Okay, those are all the parts of that equation. All right, this is how you remember how to translate them. Okay, how to move them. Okay, so this is, we did this lesson many months back already. Okay, so it's been a while. So maybe you forgot, or maybe you still remember. But that's kind of like a really quick reminder. Here's what the equation looked like, and here's what each part does, right? A is the amplitude. We called it our kind of like our slope, right? But it tells you whether it opens up or down. H tells you to move left or right. K tells you to go up or down, okay? Just depending on what's given. All right. Are we okay with that one, with this problem? All right. Question number 2. Whoops. So for question number 2, it says identify the vertex, the axis of symmetry, the maximum or minimum value, and the range. Okay. So right now we'll talk about all those little pieces, but let's remind ourselves of where we find these things. Okay. So I'm going to kind of move a little bit more to the side right here. Y is equal to a times x minus h quantity squared plus, actually, no, I'm sorry. That's not the equation they gave us. They gave us standard form. So that's ax squared plus bx plus c. Now, if they want the axis of symmetry, which was one of the things that they were asking us for, okay? The axis of symmetry is x equal to negative b over 2a, okay? So if they say, what's the axis of symmetry? You plug in a and b into that equation, and whatever you get, that's your axis of symmetry. If they want the vertex, which they did, if they want the vertex, then your x value for the vertex is negative b over 2a. In other words, your x value is your axis of symmetry. Then you get the axis of symmetry and you plug it into the equation to find y. Okay, so we're going to do that right now so you can see it. Okay, and then they asked us if it's a max or a minimum value. Well, if the graph opens down, then the vertex, bless you, that point up here would be a max. Okay, if the graph opens up, then the vertex, which would be way down here, would be a minimum. Okay, so when they ask you find the max or the min, they're asking you, is the vertex a high point or is it a low point? Right? And that's all depending on what? What tells me if it opens up or down? A, right? That's dependent on A. And then they asked us, what's the range? Okay. So when they ask us what's the range, they're saying how low does it go? How high does it go? Okay. So the range is, you're going to say low to high. Well, I don't know if it's going to be in parentheses. It can be in brackets. It depends. Okay. But usually, if I'm being honest with you guys, usually it's like this or else it's like this. It depends on what the actual numbers are. But usually one side is bracketed, the other side is open because one of them is going to be an infinity. Okay. So let's look at this problem. It says identify the vertex, the axis of symmetry, the max and min value, and range. Okay, so first thing I'm going to look at, I notice my A term is positive, right? If my A term is positive, what should I have, a maximum or a minimum? A minimum. They did say minimum, so far I know minimum value makes sense. I don't know if that answer is right, but so far it makes sense. So that makes sense. I know it's going to be a minimum value. Okay, so that's good. Now let's find the axis of symmetry. X equals to negative b, which is a negative 6, over 2 times a, which is 3. So x is equal to 6 over 6. So x is 1. This is my axis of symmetry. Is that the correct answer for my axis of symmetry? According to what they wrote? No, they said it's 1/4. So this is where it's wrong. That means everything else is going to be wrong. Okay? All the rest of it is wrong. So let's find the vertex. So the vertex is the axis of symmetry, which is 1, comma, something. Okay, remember, it's your axis of symmetry. You're going to plug that into your equation. Let's plug in a 1 into my equation. y equals 3 times 1 squared minus 6 times 1 plus 2. Well, that's 3 minus 6 plus 2. So, bless you, that's negative 1. So my vertex is 1, negative 1. So here's my vertex. Here's my axis of symmetry. Okay. They asked me, is it a minimum? Yes, it is, right? Vertex, I can put like min right here. I'll put on the left side. That's a minimum value. Okay. So if the vertex is a minimum value, that means that the graph looks something like this. I'm going to kind of draw it over here. And this point is 1, negative 1. The lowest it goes is a negative 1. So my range, so I'll write it right here, is going to be from negative 1 to positive infinity. Okay, this is my range. Why is it negative 1 to positive infinity? Because it goes as low as negative 1 for the y value. Range is always y values. So it goes as low as negative 1, but then it just keeps going up. It goes up forever. So it goes towards infinity. Infinity never uses brackets. It's always parentheses. Okay, so these are the answers that they're wanting us to do, which I forgot to circle this one here. But I found my axis of symmetry, the minimum vertex, and then the range. That's everything they wanted. And I pointed out where they made the mistake. So obviously, if the axis of symmetry is wrong, the vertex is wrong. Okay, the range is wrong, the minimum value is wrong, everything's wrong. Once the axis of symmetry is messed up, everything's messed up. Okay, so you got to be really careful with that. Okay, so the range, I kind of use this. Let's just pretend that I had graphed this, right? So if I had graphed it, it would be something like this. So that point would be at negative 1 on the y-axis. Well, I don't have it. Hold on, 1, negative 1. It would look more like this. Let's be a little more accurate. So you see the y value is at negative 1. So, and then from there, the graph just goes up. So what's the lowest it goes? Negative 1. And then what's the highest it goes? To infinity, because of the arrows, right? They keep going up. So it's from negative 1, how low, to how high. Range is always low to high. Okay? So, but yeah, so these two questions, pretty involved questions. Okay? That's why I kind of want to work with these with you guys, because I want to try to reintroduce everything that you're supposed to know about quadratics. And then once I do that, if I can't finish the rest of the homework, then it's okay. I've gone over the meat of it, right? So any other questions with number 2? So you can see how involved these problems can be. And it doesn't mean that when you take the CASP, they're going to be this difficult. But they just might say, well, what's the vertex? Well, then that means you got to find the axis of symmetry and then plug it in. They might just say, is it a max or a min? Well, if it's a max or a min, all I got to do is look at A. If A is positive, it's a minimum. If A is negative, it's a maximum, right? So, but they're just telling you, like, try all this stuff. All right, let's see this one right here. It says a ball is tossed in the air from a window. Its path is described by that equation where y represents the height of the ball in feet above the ground, x seconds after it is tossed. What is the vertex form of the equation? What is the maximum height of the ball? Okay, so the vertex form of the equation, I'm trying to remember, did I ever... Well, I can do it a different way. Never mind. I was going to say, like, did I ever teach you guys computing the squares? But not yet. But there's a different way. All right. So in order to write a standard equation, this is standard form. Okay. Give me a second. Let's see. This is standard form. Okay. Standard. Whenever you're given something in standard form, you can rewrite it in vertex form, the way they wrote it down there. Okay. Now they said that they made an error, so most likely the error is probably the vertex, but let's find out. So all I need is my h, my k, and my a. All right. If I want to write it like this, y equals a times x minus h squared plus k, I need a, h, and k. Do I know any of those letters right now automatically? Do I know either A, H, or K? I know A. What's A? Negative 16. So I'll go ahead and start with this. So that means I need my vertex, right? My vertex HK. I need my vertex. So that means I got to find my axis of symmetry. I got to find my vertex. So let's find my axis of symmetry. So AOS is x equal to negative b. That's negative 8 over 2 times a, which is negative 16. Well, that's negative 8 over negative 32, which is positive 1/4. So they got the axis of symmetry right. They have that right. So that means they must have messed up on the K value then. Well, if my axis of symmetry is 1/4, let me plug it into the equation. Y equal to negative 16 1/4 squared plus 8 times 1/4 plus 12. 1/4 squared is 16. So this is or 1/16, sorry. And then this 8 times a quarter is 2. And then I have a 12 there. So this basically becomes a negative 1 plus 14, which is 13. What did they write as K? They wrote 12. That's wrong. So it's a 13. So all I need to do is just write my equation. Y equals negative 16. X minus 1/4. Remember, X is 1/4. So when I put it into H, it should look negative because X is actually positive. It should change signs. Plus 13. And this is my equation. Okay. So what I had to do here, in order to do this problem, I had to know what I needed, right? So they wanted me to write something in vertex form. This is called vertex form. The y equals to a times x minus h squared plus k. The one they gave us originally is called standard form. That's the one that has the ABC in it. Okay. So they wanted in vertex form. So I wrote it out, vertex form. And I said, I need to know A, H, and K. I automatically knew what A was because A is the same in both equations. So A was negative 16. But I need to figure out H and K. In order to find H and K, I had to find my axis of symmetry and my vertex, right? Once I found my vertex, I knew 1/4 13th. Actually, I didn't even label it, but I'll put it right now for you guys. My vertex is 1/4 13. This is my HK, 1/4 13. So I plugged it in, 1/4 13 into my formula. Okay? And that's how you do that. Now at this point, I've kind of shown you everything you need to know to do this stuff. But like I said, I want to try to do as much as I can. If you guys don't mind, I kind of want to work through more of these problems with you and then hopefully leave you with no homework. But I know that's kind of like a big ask unless you guys want to literally sit here for the whole class period. But some of these are quick, which is kind of nice. Okay. But here we go. For these exercises, identify the error, okay, in planning the solution or solving the problem, then write the correct steps. So they say this in factored form is this. They're saying this is the correct answer right here, okay? Is that the correct answer? Well, let's check. What's x times x? That's x squared. What's x times negative 6? That's negative 6x. What's negative 4 times x is negative 4x. And negative 4 times negative 6 is positive 24. So that's x squared minus 10x plus 24. Is that the same as the equation they said I was supposed to factor? No, it's not. It's not. This is minus plus. Look at that one. Minus minus. So it's wrong. Okay? So then this is not correct. This is messed up. So now I got to factor it. They want me to factor. Now this doesn't take too long, thankfully. A times C is negative 24. B is negative 10. Two numbers that multiply to negative 24 that add up to negative 10, bless you. What would I use? One is negative, one is positive. We already tried 6 and 4 and it didn't work, right? It's going to be 12 and 2. Okay, negative 12 plus 2 is negative 10. Negative 12 times 2 is negative 24. Your answer should be this. Notice these are not, they don't take that long. The first three take forever because we're using definitions to do the work. Here, we're just kind of using some knowledge that we've gotten before. That one's not so hard. Okay? So remember, what I did was I got their answer and I worked it out and then I checked it and it doesn't match. So that doesn't work. Okay? So then I had to do it myself. Look at question number 5. What are the solutions for that? Well, remember, if you're trying to solve these, you're supposed to set them equal to 0, right? Notice they never set it equal to 0. That's the error. They did all that work by leaving it equal to 4, equal to 4, equal to 2. Okay, and in order to solve a quadratic, you must set it equal to 0. So in other words, this should have looked like this. X squared minus 16x plus 60 equal to 0, because this 4 should have been brought over. And then I would factor 60, negative 16, that's 10 and 6. That would be a negative 10 and a negative 6. So your factors would be x minus 10, x minus 6 equals 0. What are my two solutions? All right, so 10 and 6. So there should be an extra one right here, right? So again, not a hard problem, not as involved as the other ones, okay? These next ones are just kind of like some questions, I think. What are the solutions to that? Use factoring. So 6x squared plus 11x minus 10 equals 0. So they're saying the two answers are 3 halves and negatives 2/5. But I'm going to have to factor it because obviously there's errors, they said. Okay, so let's check. Okay, let's go ahead and factor this. So a times c is negative 60. This is 11. So what gives me 11 from 60? So 2 and 30, 3 and 20, 4 and 15. 4 and 15 do. So a positive 15 and a negative 4. Okay. Now, I have to divide by 6, right? Because a is 6. So if I divide by 6, I get negative 2/3 and positive, if I divide by 3, that'd be 5 halves. Okay, so here are my factors. X plus 5 halves, x minus 2/3 equals to 0. Now you could move the 2 to the front of the x and the 3 to the front of the x as well, but since I'm solving, I'm going to kind of skip that because I can solve a lot easier. My two answers are negative 5 halves and 2/3. So this is wrong, and this is wrong. Remember, I didn't fix the factor. I left the fractions there because I'm not trying to show a factored form. I'm trying to solve. If I would have moved that number over, I'd still have to divide later. So I'm saving myself some work. Okay? All right. Number 7. Which of the following best describes a graph of a quadratic equation with one real root? Now, I do want to remind you guys, what they mean by roots is how many times it crosses the x-axis. So like this graph would have one solution because it touches the x-axis once. This graph would have two solutions because it touches twice. If it doesn't touch, then no solutions. Okay? So if it has one real solution, what has to happen? Well, If it has two x-intercepts, does it have one answer only? No, it has two. It doesn't cross the x-axis. That's no solution. Okay? Its vertex lies on the x-axis. It's on the x-axis, like this one. It's C. Okay? Its vertex lies on the y. Who cares if it's on the y-axis? That doesn't matter. It's all based on the x-axis. So your answer is C. How many problems is there? Is this like 2 more and we're done? Okay, good. So you guys want me to keep going? I wasn't going to go more than 30 minutes. Just finish it. 5 minutes, let's try. The graph of the parabola y equals to -2 times, this should be a power of 2, guys, right here. I don't know why I printed like that. That should be a square. Y equal to -2 x minus 3 squared plus 4 has a vertex of 3, 4. If the parabola is shifted 5 units to the left and 3 units down, what is the equation of the new parabola? Remember, these are all squares, okay? So this, I don't know why I printed like that, but square, 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 square. Sorry about that. Well, guys, let's think of it this way. They said 3, 4. 1, 2, 3. So 3, 4. They're saying the point is here at 3, 4. They said, what is the equation of the parabola if we shifted 5 units to the left and 3 units down? So let's see. 1, 2, 3, 4, 5. And then how many units down? 3 units down. So 1, 2, 3. This point right there is -2, 1. -2, 1. So all I got to do is write this equation with a -2 and a 1. The equation should look like this. So the a term's not going to change. X plus 2, because it's a -2, right? The x value is -2. That means you write it as a positive. Squared plus 1. Which equation is that? A. Notice you didn't really have to do too much work. You just kind of had to graph the original vertex and then graph where it ended up and then rewrite the equation. That's all. Last one. I appreciate you guys sticking with me, even those that kind of dozed off a little bit. Hopefully you wake up. All right, last one. The graph relates to the height of a ball tossed in the air to the time after the ball is tossed. What does the y-intercept represent? What do you guys think? The maximum what? I think this is the graph relates the height of the ball tossed in the air at the time when the ball is tossed. What does the y-intercept represent? Y-intercept, that part right here. That point. What's the time at that point? It's 0. It's 0. The height is 6, right? This is 2, 4, 6, 8, right? So the height is 6 at this point right here at time equals 0. If I'm throwing a ball, what does it mean at time equals 0? I'm about to throw it, right? So doesn't that represent the starting height that the ball is at? And then after I threw it, that's why you see the graph go up. What was the highest that it reached? 14, right? 14. Remember, it's going by 2. So the maximum it reached was 14, and that happened after 3 seconds, right? It got a 314. That's its vertex, the highest point. But let's see. To answer this question, what does the y-intercept represent? The maximum height of the ball was 6 feet. Nope, max height is 14. The ball was tossed from 6 feet above the ground. That sounds about right. The ball landed after 6 seconds. That is true, but that's not the y-intercept. That's the x-intercept. The minimum height of the ball was 6 feet. Well, that's not true because it eventually reached the ground. So it has to be B. That's when they tossed the ball. Okay, and there you go.